Now here what we have is a car covers 90 kilometers in 1.5 hours towards east. Calculate the displacement. So the displacement is 90 kilometers due east. Okay, so that is something that you should know. Uh, in displacement, what do? We write down the direction. Now it wants velocity. So in this case, velocity is distance upon time because there is no acceleration. So we are not using the other formula. Okay, so 90 kilometers in 1.5 hour. Now, when you have time as 1.5 hour, so that will be 3 by 2 hours. So that is 3 by 2, and that is 90 into 2. So this is 30. So this is 60 kilometer per hour. Now this is the velocity, 60 kilometers per hour. This is the first answer. And now we want the answer into meter per second as well. So we know that V is equal to 60 into 5 by 18. This is 6 tens are, 6 threes are. So this is 50 upon 3. You cannot leave your answer in fraction. So therefore you are expected to write the answer in decimals as well. So correct up to 2 decimal places is the expectation. So it is 16.666. So the velocity is 16.67 meter per second. A racehorse runs straight towards north and covers 540 meters in 1 minute. So again, displacement will be equal to 540 meters in the north direction. Okay, the second question is the velocity in meter per second. So this is distance upon time, that is 540 upon 60 because this is 1 minute. So this will be 9 meter per second is the velocity. Okay, and they want us to write the answer in kilometer per hour as well. So that will be 18 by 5. And so this is 9 into 18 will give you 162 upon 5, and the velocity will be uh, 32.4 kilometer per hour. Change in velocity. Now, how do you write change in velocity? V minus U, and this is 54 kilometer per hour, and the time given is 1 minute. Okay, now this is in kilometers per hour. So that can be done as 54 into 5 by 18, and that will give you an answer of 15 meter per second, and the time has to be in seconds, so that is 60 seconds. So they are asking us for acceleration. So acceleration is change in velocity upon time, so that is 15 upon 60, 15 fours, and therefore the acceleration is 1 by 4, that is 0.25 meter per second square. Okay, now they want the acceleration is meter per hour square. So now how do we change that? So say for example, the change in velocity, that is v minus u upon t. So this is 54 kilometer per hour, and the time also we can express in hours. So 1 minute is equal to 1 upon 60 hours. So this will be 1 upon 60. So we get 54 into 60, and that will be 3,240 kilometer per hour square. Okay, so if they want in kilometer per hour square, we have this in kilometer per hour, and we have the speeding car change the velocity from 108 kilometer per hour to 36 kilometer per hour in 4 seconds. you have to find the acceleration in meter per second square and kilometer per hour square again. So u is equal to 108 kilometer per hour and v is equal to 36 kilometer per hour. So when you talk about change in velocity, that is v minus u, and that will be 36 minus 108, and that will be minus 72 kilometer per hour. Okay. Now I will also write it in meter per second. So that will be 5 by 18. So we get this will be minus 20 meter per second. Now acceleration is v minus u upon t. So this is negative 20, and time, which is 4 seconds, I use it over here. So my answer is minus 5 meter per second square. Okay. So now if I want kilometer per hour square, then what I can do is I can rather use 72 kilometers per hour and 4 seconds. Now that will be 3600 hours. Okay. Just to tell you that 1 hour is equal to 60 minutes, and 60 minutes have, each minute has 60 seconds. So that is 3600 seconds. Okay, so this is minus 72 into 3600 upon 4. This will be 900, okay, 1800 kilometer per hour square. Okay, so a train starts from rest. So the very first thing is we note down what is given. A train starts from rest, picks up speed of 20 meter per second. So final velocity is 20 meter per second, and it does so in 200 seconds. So the time is 200 seconds. Okay. It continues to move at the same rate for 500 seconds. So what I will do is I will first find out the information with only this. So I'm going to take only this part of the sum, and look what I do. I find acceleration. So that is v minus u upon t. So that is 20 minus 0 upon 200. So that is 20 upon 200. And that will be 1 by 10, or 0.1 meter per second square. So this is the acceleration. I also will find out the distance covered. So it is ut plus half at squared. So this is 0, and this is 200, plus half into 1 by 10 into 200 into 200. So this cancels, this will be 10. So this will be 0 plus 2000. So I call this as S1 is 2000 meters. Okay, so this is the information that we collect from the first part of this answer. Now the next part is it continues to move with the same rate for the next 500 seconds. So, okay, so that is my second piece of information, that u is 20 meter per second and time 2 is 500 seconds, and acceleration is 0 because it continues to move at the same rate. So the distance covered is equal to ut plus half at squared. So that is 20, and this will be 500 plus half into 0 into 500 into 500. So this will be 10, and that will be 10,000 plus 0. So this is 10,000 meters. I call it as S2. Now, then what they say, it is then brought to rest. So then it is brought to rest in 100 seconds. So what we have over here, so your initial velocity is 20 meter per second, your final velocity is 0, and the time taken to do that is 100 seconds. So what is the acceleration? V minus u upon t, and that will be 0 minus 20 upon 100 minus 20 upon 100, and acceleration is negative 0.2 meter per second square. And so therefore we will get is deceleration or retardation is equal to 0.2 meter per second square. And now what I will do, I will find the distance covered over there, that is ut plus half at squared, and this will be 20 into 100 minus half into this will be 2 by 10, and the time is 100 into 100. So this will be 2000. This and this get cancelled. The 0 also get cancelled, and that will be 1000. So 2000 minus 1000, what do we get? We get S3 as 1000 meters. Total distance covered. Okay, so students, that will be 2000 plus 10,000 plus 1000, and that will be a total of 13,000 meters. Okay, and they want us to calculate the average speed. So let's speed is equal to the total distance upon total time. So that will be 13,000 divided by, initially it was 200, then it was 500, and this was 100. So this will be 13,000 upon 800 seconds. So two zeros are cancelled, and this will be 130 divided by 8. So again, we have to write our answers.
16.25.
16.25 meter per second is the average speed. That is, now this graph will be a speed and time graph. So I will have like 0, this is time, and since it is 800, so we will have like 100, 200, 300, 400, 5, 6, 7, 8. So this is 800 seconds, this is 100 seconds, and so on. And the maximum velocity was 20. So this is 10, and this is 20, and this is 30. So this is velocity. Okay. So now we know that in 200 seconds, the velocity became 200. So this is 200 seconds. So the velocity became 20 in that case. And then for 500 seconds, the next 500 seconds, so that is 300, 400, 500, 600, and 700. So till then, the velocity was constant. And in the 100 seconds, that is from 700 to 800, the velocity became 0. So that is how you have, that's the graph.